Hi, I'm Mark Emmanuel Dilaab. What is this that I'm holding? This is a source of light. So, I want to discuss to you about light. Off the light, please. So here we go. We're going to talk about light. So, what is light? Light is the part of the EM or electromagnetic spectrum which we can see. Also, light travels in straight lines called rays. A bundle of rays is known as a beam of light. So this is an example of rays or beam of light. First, we have here a ray which consists of one line. And the second, we have a parallel beam which consists of three lines. And they are parallel to each other. And the third, a divergent beam. A divergent beam, they separate from each other. And the last one, a convergent beam. A convergent beam, they meet to each other. Next, please. A luminous and a non-luminous. Luminous objects are those that gives off light on its own. Example, light bulb. And next, sun. And non-luminous objects are objects that do not give off light on its own. Table, board, moon. Can you put it back? In short, luminous objects are the one who gives off light, who give lights to us. They are natural lights like sun, stars, and many, many more. And non-luminous objects that they are luminous that only reflects light, or they're just borrowing light from a luminous light. Okay, next please. Reflection. Reflection is the bouncing of light rays off a surface. We are able to see the non-luminous objects as light is reflected of them. When light hits an object, an obstacle, it reflects. So, next please. Reflection. This is our example or example of reflection of light. This is the angle of incidence, and this is the angle of reflection. This is the incident ray, and this is the reflected ray. And this is where the light bounces or reflected the surface. Angle of incidence and angle of reflection is equal to each other. Next, laws of reflection. We have the laws here, the reflection. Incident ray, the reflected ray, and the normal all lie on the same plane. The angle of incident is equal to the angle of reflection. Just like I said before, but I just... next. Never mind. Reflection for different surveys. We have here regular reflection. Diffuse reflection. Okay. When light hits a smooth surface, it reflected in a proper way, or the usual reflection that we see. While the light hits a rough surface, it diffuse. It means when light hits a rough surface, it's chaos. It's chaotic. You know what I mean. Next. Properties of image formed by plane mirror. Here, we have the properties of image formed by plane mirror. Here, we have the same size as the object. Laterally inverted, left to right inversion. Upright. Bridge wall, image. Cannot be caught on screen. Object distance is equal to image distance. So, no! Put it back there. So, that's the properties of image formed by plane mirror. We can see it every day, and we can experience it every day in our lives. That's the property of image formed by the plane mirror. Next, please. Ray diagram for reflection. So this is a diagram for ray reflection. So we can see here the observer looking at the image, and this is the object. So that's a diagram for reflection, ray diagram for reflection. Right, next, please. And next. Okay, yeah. What's this? Yeah, next. Thank you. I was about to tell you to next it. Refraction is the bending of light when it enters from one transparent medium into another. It is caused by the different speeds of light in different media. The greater the optical density of the medium, the slower the speed of light. Refraction. Remember that. That is refraction. Remember that. Next, please. So, refraction. Incident ray and the angle of incident. Reflected ray and the angle of reflection. Angle of emergence. And the emergent ray. This is the normal. When refraction, it means when light passes, when light passes to a prism, when a light passes to prism, it refracts light. You can see the different colors of light, like red, yellow, orange, and many more. So that is the meaning of refraction. When we do that. Okay, good job, projector controller. So here we have the laws of refraction. The incident ray, the refracted ray, and the normal all lie in the same plane. Remember that. They all lie in the same plane where the light refracts. For two particular media, the ratio of the sine of the angle of incident to the sine of the angle of refraction is a constant. So we have the formula for the refraction. So here we have the normal equals sine angle of incidence, and the over sine angle of reflection. So this is the Snell's law. Remember that. This is the Snell's law. Please remember that. Next, please. Refractive index. When light passes from vacuum or air into a given medium and other water, the constant ratio of sine angle of incidence over angle of ray reflection is known as the refractive index. Normal. And for that medium, n is equals to sine angle of incidence over sine angle of reflection. See? I'm right. Well, I just guessed that. Next! Speed and refractive index. Speed of light in vacuum. The speed of light is equals to 3 times 10 raised to positive 8 meters per second, negative 1. Light is found to move slower in optically denser mediums. And other glasses and water. And we have here another formula for light. N is equals to speed of light in vacuum, speed of light in vacuum, in medium. N is equals to C over B. This is the speed of light, and this is the C. Okay, next. daily phenomena or refraction. Here we can see experience the refraction in our lives or in our daily life. So here we can see the example of refraction. Swimming pool and ponds appear shallower than it really is. Object is at a deeper depth than where it appears to be. Bent objects in liquids. So you can see the example here and the meaning description of the example here. Okay, next. Total internal reflection. So we're talking about reflection, total internal reflection. Light ray is unable to exit a medium. Occurs when ray of light passes from a denser to a less dense medium. Angle of incidence in the denser medium is greater than the critical angle. Next, please. Critical. Sorry. To continue. Critical angle. The angle of incidence in the optically denser medium for which the angle of refraction in the less dense medium is 90 degrees. Sine C equals to 1 over n critical angle. This is the critical angle. This one. And this is the refractive index. So this is refractive index. Okay, that's all I want to discuss to you about light. I hope you learned something about light. This is an important discussion because light is a great part of our daily lives. So, I hope you have learned something and you